right, thank you. So I've been studying Linux for about 10 years now. These are all I make a lot of tutorial videos, so these are my links, my archive.org, BitChute, and YouTube URLs. You can find my slides on the Slack channel. I'm also posting 3 different cheat sheets covering ZFS, Btrfs, and XFS, the 3 file systems that I'll be covering today. So I'm a dual certified Linux administrator. I just passed the Linux Engineer 201. I like to do a lot of forensics analysis, memory forensics, kernel hardening, and stuff like that. If you want to get a hold of me, this is, if you want to get a hold of me, there's my Telegram handle, the first one here, my Twitter, and all my GitLab projects there. All right, so the first file system, and I ran out of room here, so the first file system we'll be covering is ZFS. There's also Btrfs and XFS, and then I'll kind of use a few different tools. Each slide will cover like implementing it, and all the commands and syntax I'll be using are in the cheat sheets, and my slides can be found on the Slack channel. I'll post that later. So here's the talk layout and the cheat sheets. They're long URLs, so I'll just post them in the Slack. That'd be easier. So here are the 3 ones that are covered. There are also other Linux file systems that aren't covered. I'm already working on like a part 2. Here's some of the other file systems that Linux uses that are pretty common and interesting file systems. So this is the Linux storage kind of diagram. There's 2 parts here, but if you see here, here's like a lot of the common ones. So, oops. And here's the second part. So it's a very complex, and there's a lot of different implementations, solutions you can use for file systems. So this is like the networking file systems here. Okay, so, and these are my URLs for Linux, or the ZFS video. I broke it down more, and I'll post those later, but I have one video with all the topics, so it's probably easier to do that. And at the bottom of the slides here, you'll find the URL for the ZFS notes. And once I get to the Btrfs and the XFS, it'll be posted there at the bottom as well. So the different ZFS is incredible. It blows every other file system out of the water. Some of the common features are like ACL. You can inherit them down all the way down to the folder, to the file, extend attributes. Take us out here. So you have like something called vscan, which is ZFS is based on a BSD. When they ported it to Linux, it's now called OpenZFS. It was originally a BSD file system. Recently, really funny thing happened. The BSD guys have been bragging about the ZFS file system for years and how they're superior to us, but recently they went to compile and their code broke. And they couldn't go back to previous versions. So now the BSD is actually porting off of the OpenZFS Linux implementation, which is really, really funny. So other options here. So you have the vscan, you have zoning, you have temporary file systems, you have read-only. So some of the other things that won't be covered are like, this is an intro talk, so I won't be talking about like rating or the ZFS log or caching and stuff like that. Just kind of the common features that ZFS, Btrfs, and XFS has, how to implement them, the syntax, how to do so, the output from when you use this syntax. So here's some more. There's 3 slides of ZFS features. It's pretty crazy. So it's called the Zeta file system. They say theoretically they're more. It's bigger than all the numbers in the galaxy or something like that. It's pretty crazy. So one of the really interesting features is with ZFS, they checksum all the way down, and I'll cover this on another slide, but they have SHA 256 checksums, so it's like for the files, the directories, all the way down. So if like the checksum gets corrupt at the bottom, you're able to actually correct it further up the file tree. So you have snapshotting, and an interesting thing about ZFS and Btrfs, with snapshotting, you can actually send files and back them snapshots and stuff like that, and you can send and receive, and you can send it to a file, or you can actually send it over the network to other machines. So here's a kind of general concepts. So ZFS, the way that it's implemented is it has a pool storage basically. So you're able to gather several different disks. So it's similar to like LVMs. I don't know if you guys are familiar with LVMs. But you can pool several devices. So from the ground up, it's really built for like RAIDs. So ZFS, the fundamental foundation that it sits on is something called a VDEV. And these are all the different implementations that you can do from a VDEV, create disks, mirrors, RAIDs, spares, caches, and logs. So if you think of the ZFS file system, it's kind of like LVM, where it has an outside, it covers, I don't know how to describe this, like an Oreo cookie. The VDEV is like the chocolate part of the Oreo cookie, and the file system is the middle. So ZFS is, one of the things that are really intriguing is it's self-healing. So when it finds, it checksums everything, and it's able to correct different blocks and stuff like that. It prevents like bit rot and stuff like that. This is from the FileSystem documentation. I forget to put that link in there. But so here are some attributes about ZFS. So you can create multiple copies. So if something becomes corrupt, you're able to use another copy and actually correct anything. You're able to create like file system overlays. You're able to turn on and off the execution of like code. So if you create a folder and you say no execute in this folder, like scripts won't run and stuff like that, which is, you know, if you're doing like forensics and stuff like that, and you're like doing memory forensics on like malware, it's pretty useful. Same thing with vscan, it scans for viruses and stuff like that. X attributes, so extended attributes, and then like zoning as well. So you can also compress, and you can compress by the folder. They have different types of compression. You can set a context. So if you use like SE Linux, you can define context. You can also do file system limiting and read-only file system. And not just file systems, but folders as well. So you have primary caches, secondary caches, and non-blocking mandatory. And you have different kinds of ACLs. I think it by default uses POSIX. There's also different kinds of checksumming that you can use. Okay, so these are all the different attributes that you can get. So I use Parrot Linux, so you can tab complete. So these are all the different options you can get: ACL inherit, ACL mode, all features or all attributes. And these are all the set features with ZFS. All right, so the first thing you want to do with ZFS is import pools. So you import the pool, and then you're able to do other things. So it's like mounting, basically, for any other file system, except for since it goes by the pool instead of individual disks, or if you use RAIDs and stuff like that. So once you import it, then you're able to list different attributes. So you have like the amount that it's used, how many copies, if it's read-only, the mount point, X attributes, zones, ACL, ACL modes, and inheritance, and stuff like that. So here we're getting the X attributes. So these are the different folders. You see the value here is on or off. And here I set the X attribute off for that pools, and that's the audio folder. Here I'm getting and setting the compression for folders. So it's pretty easy syntax. You just do ZFS and then set the attribute equals on or off the pool, then the folder under that pool. So you see here it was off, and I turned it on here. So whether or not that folder can execute files within that folder, so scripts, like I said, if you're doing like memory forensics and stuff like that with like malware, it's a common thing to do, is to turn it off so that it won't, whether it's, like a worm or something like that, you don't want it executing. So whether or not you want the folder or the pool to be read-only, so here it's off. Oops. That should have been on. But here in the set UID bit, so whether or not the set UID bit is people that aren't the owner or the group, people that would be considered other within POSIX terms, whether you want that on or off. Usually you want that off because you don't want someone that's not you executing code. Get or set zoned attributes. So here it was off and then turned it on there. So this is explaining ZFS, and this is from Scale this year. ZFS checksums work all the way down the file tree. So say you were to have corrupt data checksum near the end here at the data portion, you can use checksums from the folder or like higher up the tree to correct the checksums lower down the tree. So that prevents all those different options, bit rot, accidental writes, stuff like that. So here's the checksums. See the value is 256. So 256 is currently a secure checksum. I believe they'll be transitioning up to, I heard that SHA-1 has been, isn't secure anymore. So I would assume it's going to take them quite a few years to get to 256, but after that it goes to 512. But for right now, 256 is a secure standard. So all those folder has that value. So like I said, another option is setting multiple copies so that if something becomes corrupt, you're able to rebuild with a copy that isn't corrupt. These are the vScans, so virus scanning engine. And they turned it on here. It was off over here. So deduplication. And here are a list of different commands that I executed. You can do that with, I don't know if anyone's is familiar with the history command with Linux, but I just cut the output to just be the commands, not like the numbering and stuff like that. All right, so now this is Btrfs. That's my YouTube and archive.org URL. So this is from the Btrfs site. These are all the different features. So this is to create a partition. I'm specifying that it's going to be single. Btrfs is another file system that from the ground up is built for RAIDs. But in this option, I'm just specifying a single disk. That's the label there. Metadata is single. That's the output from creating Btrfs partition. So Btrfs only has a couple different properties. So you can set read-only, label, or compression. So that's how to list the properties and get them. So Btrfs has subvolumes. So this is how you create a subvolume with Btrfs. ls, so I'm listing the subvolume that I created, and I'm naming the subvolume Btrfs-test. Here I'm creating a snapshot of Btrfs test. So the folder is called Btrfs test. The snapshot is Btrfs test-snap, and then I'm listing the folders. Here I'm creating a read-only snapshot. So -r creates the read-only. So here I'm showing the use of the file system, the Btrfs file system. Here's more options. So it's human readable. Forgetting what SI is. It's some kind of output option there. So here's showing stats. So I don't know if anyone's familiar with DF or DU. It's going to show like disk usage and different statistics related to the disk. So a really interesting thing with Btrfs is you can show the super block information. So here we're showing it's a inspect interval dump super. So, and you can back up that information as well. So usually when disks become corrupt and unreadable, it's because the super block has gone bad. They usually only provide like 2 super blocks per disk, which is odd. I feel like they should put a lot more super blocks than that in it. But so here's another option is dump tree. So it's going to show the extents, the UUID, etc. So here's the tree stats. So it's going to show cluster size, stuff like that. So like I said, this is made for like raids and stuff like that. So be much more useful if you used a Btrfs raid. So here we're mounting the Btrfs file system with LZO compression. So the first one shows the list, the options, and then the second one, we're using the mount command, -o, so options, we're using compress, LZO, the dev/SDB is the disk, is the device file, and then mount is the directory. So, and then the third one there, I'm making that directory and mounting it at that level. And then the third one, I'm CD, so I'm changing directory into there. And then I'm showing that I've mounted and I'm currently using that disk. So here are, if your Btrfs file system has become corrupt, you can use Btrfs FSCK, which fixes the file system. So here I'm checking the data checksums, and then I'm showing the progress, and then dev/SDB is the device file. And then that's the output from checking that file system. So here's another way to do basically the same thing. So Btrfsck is its own binary, and this is using the Btrfs binary. Okay, so I haven't posted the XFS yet, videos yet. So this is, here I'm mounting the XFS file system. So -t is the type of file system it is. Dev/SDD is the device file, and mount/XFS is the area that I'm mounting it at. and then dash O read write. And then the second command is unmounting the file system. So I have the video here at this location, and this is the XFS cheat sheet that I created. So one of the most interesting thing about XFS is that something called XFS dump. You're able to actually dump the XFS metadata to a file and recreate it if your disk becomes corrupt. So here I'm dumping it to this file. So I named the file XFS backup, and that's my folder. And this is the mount directory. So I'm using Zulu mount in this instance, and Zulu mount mounts to run/media/public/XFS. So here's the second part of the output. Then I'm restoring that metadata back into the disk. So here I'm showing that I want it to be a very verbose output trace. I'm using this file, home/my username/XFS backup, and I'm restoring it to this disk, run media public XFS. And then that's the output of it as I restore the data. And that's the second part of the output there. I know I'm going really fast here. You can find my slides on the Slack. I'll be posting those. Okay, so these are some file system tools. I don't know how many people are used to the terminal, so I included a few different GUIs just to kind of show that Linux does have a lot of GUI environments as well. So these are the tools that I'll be covering. SmartCTL, which will show like smart information about disks, their health, different like tests and stuff like that. Hdparm shows a lot of hidden attributes about disks. Hdtemp shows the temperature. Fdisk and fdisk, sfdisk, and blk are just gonna like list them, show the attributes, kind of general information, and then fsck is gonna fix disk. All right, so this is SmartCTL. Here I'm listing -A is all, and dev SDA is the first disk, and I'm grepping the smart information. So I'm saying, is the support there? If yes or no, currently it is disabled. So I want to take SmartCTL-S on. I want to turn the smart data on for that disk. So then it shows the output that it has been enabled. So here is the output from SmartCTL-XAll, so all information for the first disk printed. So you see it'll show like the serial number. The WWN is worldwide number. So if you're creating a network file system, it uses that number, the firmware version, sector size, stuff like that. So SmartCTL also has a GUI called gsmartcontrol. So this is the general tab. It'll just show, just like the command line version, the exact same information, just as a GUI. Here are more verbose options. So the most interesting thing about Hdparm that I found is I read a Linux forensics book, and they showed that people that are manufacturing hardware is actually using the firmware layer to create hidden file systems. So you can use Hdparm, and there's two different attributes that they use. I don't think I put them in this slide, but I can post them. But you can find them, find out how much like data it's using, and you can actually disable them. But they're like using it to collect metadata, and then whenever your hard drive is online, it actually uploads the metadata to servers, which has been a very interesting discovery. So here's some more drive information. And that's the last part there of all the different attributes that disk has. I'm sure if you have a better hard drive than me, there's going to be more attributes. So you can lock and you can freeze and you can put like a secure password on your disk as well. So these are the drive geometry. Oops. And here's an option with Hdparm. You can create that device file, dev mmcblk0. That's an SD card. So usually it's going to be SDA or SDB for the second disk. Here I'm asking the first syntax. I'm asking, is this disk read only? The second one I'm saying, make this disk read only. The third one is, or the second one is turning it off, the read only attribute off, and then the third one is making the disk read only. So here are a couple different ways that you can mount a disk. So you have ext2. The ISO is going to be like a DVD or CD. The ISO 9660, that's the standard for DVDs. And the third one there, UDisks CTL mount the block device. So SD or dev SDA or SDB, it'll mount that disk. So here's a GUI called Zulu mount. It's pretty straightforward. You can create like, you can mount it privately. So it's going to mount disks in their own namespace. You can also mount them publicly. So it'll like isolate it by the owner. Here's HDD temp. So it's going to show the temperature. If you do -- forgetting the syntax, you can change it to Fahrenheit as well. Fdisk, so you're listing the different disks, the sector size, kind of just general information. That's an LVM, so it'll show 3 different partitions. Fdisks part 2, so this is just some more disks. I don't know how many people are familiar with LVM, but this is an encrypted LVM, so SDA5 is going to be the encryption part, and then you have root, so that's the root part, and then you have the swap. So that's the 3 different partitions that LVM is going to create. Here we're checking like the block size. It's just kind of extra information. List disks, so it's showing the bytes and the permissions and stuff like that. So here we're showing like the block topology and the file system, so like what branches underneath it and stuff like that. The UUID and stuff like that, so unique identifier, the size. And then this is showing like a file system check, and the output of it fixing the file system. All right, so that's about it. Like I said, I'm working on part 2, kind of going over LVMs, ext4s, loop file systems, overlay file systems, stuff like that. Any questions? Yeah. To be honest, I'm not quite sure. You can look at the code on openzfs.com or .org, I believe. Haven't really looked over their source code, so I couldn't tell you. Yeah. Any other questions? Okay, so like I said, I'll post the slides. I made 3 different cheat sheets with all the syntax that I have. It'll describe it, and it'll have the syntax. And I have videos of everything I did on my YouTube archive and BitChute. All right, thank you.